So today is November 19th. It's 12:15 and you're here for Econ 249. What you're looking at is a flyer that we had in the last class. So I'm posting it again in case you missed it. I've put more information in the chat box because some of the font is a bit too light to read. It's an event on November 23rd from 5:30 to 7 p.m. There's a link to sign up. Once you sign up, I assume you will get the Zoom link to join the meeting. So it sounds quite interesting. Judah, do you want to mention something here?
Sure, and I went over it a little bit last class also. So this is an event by ISACA, the Information Systems and Audit Control Association student group at Queens College. It is an internal control, internal audit, and cybersecurity club. It started a year ago, so it's still newish, and we're having a tips and tricks for virtual interviewing. Try to get the best out of your interview. Any little bit of help to try to get that first job or internship is really, really exciting and helpful. So we're going to be speaking about that next Monday. It'll be very great. Please come.
Good, thank you. So I have polls taken in class. I have breakout rooms. We do different things during the lectures so that these are opportunities for you to participate. I've got some emails where students are asking me if I'm offering any other extra credit assignments or work, and I don't. I'm not offering that because you have opportunities like this where you can bring up your grade with participation. Remember, participation is part of the course grade. So whenever I have a poll or a breakout room or a discussion, you can turn on your audio, you could type it in the chat box, and I'm able to download a report which tells me who participated and, of course, who attended. So just keep that in mind when we go through our lectures. Now, the final exam is the same date that's set in CUNY first. So I'll talk more about that later. But today I'm going to start a brand new chapter, chapter 12, which is the last chapter that you're required to know for this course for 249, and also will be included in the final exam. So before I start with chapter 12, I want to begin with reviewing chapter 11 with a question at the end. So I'm sharing this now, and I'll give you a couple of minutes to read it on your own. Okay, so these ethics in action articles are usually at the end of each chapter in your textbook. So it's also a reminder to go to your textbook and review it if you have a question about a topic that I discuss. If you don't understand a homework question, your textbook is another go-to place. So these ethics in action is sort of a culminating question at the end of the chapter. So this particular one is at the end of chapter 11 when we just finished confidence intervals. So quickly going through this, the question is about a person who opened a computer repair business. And this person's name is Mohammed, and his repair business is Mo's Mending Station. Now, unlike the big electronics retailer, Mo's Mending Station fixes only computers, and it does not deal with TVs and phones and cameras. So it only specializes in repair services for computers, laptops, maybe virus removal, data recovery, stuff like that. Okay. And each is fixed at a low price. So he charges a competitive rate of $45 per hour for more complicated computer issues. And Mo came up with a new slogan: get twice the nerd at half the cost. And the slogan worked. He was able to grow his business, and he was able to have 6 repair technicians, an office manager. But recently, the monthly receipts indicate that the demand for his services has been slowing down. So now what he does is Mo gathers his staff for a brainstorming session. And one of the staff members, Ed, mentions that it's possible that the low prices indicate that it offers poor quality service. So Ed suggests that why don't we hire a local advertising firm to rebrand this slogan. So put the focus on twice the nerd rather than half the cost. Okay. So what this owner of the computer repair business, Mohammed, says is that he likes that idea, but first he wants his um, office manager maybe to prepare some statistics so that he can get back with the advertising firm and ask them to rebrand this slogan. So let's pretend that you're the office manager, and let's pretend that you had to put together these statistics. So Mo wants to go back to the advertising firm and say, let's focus on the time that I take to um, fix these computers and laptops. Because remember, Ed said that maybe the impression is poor quality service. Maybe that's why the price is so low. Maybe that's what customers are thinking, potential customers. So Mo is saying, okay, let's prove that our quality service is good. So as the office manager, now I'm going to highlight the points that I'm interested in here. As the office manager, you're going to select a sample so that you can estimate what the average service time is. Okay, so you're going to use this concept of confidence intervals. So what you do is you take 36 receipts, and some of the receipts are um, before the computer is repaired. So there are, when a person comes in to drop off the computer, a receipt is issued. And then when the person picks up after the computer is issued, there's another receipt that's issued. So these 36 receipts include both. It includes both when the computer is brought in and when the repair is finished. Okay, so from those 36 receipts, you find that the average service time is 2 hours and 10 minutes. So that means you found out what X bar is. That's your sample mean. And you also calculated that the standard deviation for the sample is 30 minutes. So that means you have the value for S. So now you can come up with your confidence interval. So remember, just having a single value doesn't make sense, right? It's better to have a range of values to estimate the average service time. So you can use the formula that we've discussed in previous classes, X bar plus or minus. Now we can't use Z, we are going to use T because you're dealing with an example that does not have population standard deviation, right? Population standard deviation is unknown, so you would have to use T. So your formula is T times S over square root of N. So that will help you get 95% confidence interval. So let's say you're interested in 95% confidence. So 95% confidence interval. You have all the variables once you collected the 36 receipts. And now you came up with a confidence of 1.99 to 2.33. Okay. So this is what you came up with. You went back to Muhammad and you said, I am 95% confident that, the average service time is 1.99 to 2.33 hours, which is fairly good. So what Muhammad does is he goes back to the advertising firm and tells them that this is the information they need to use. And he wants them to advertise that 99% of his customers can expect to wait between 1.99 and 233 hours to get their computers back from repair. So now my question to you is, and I'm going to put it in a poll. Um, Question is there any misinterpretation? Okay, another 30 seconds. Okay, so you can see that most of you said yes, there is some misinterpretation. Can someone explain to me why you think there is misinterpretation here? Rad, you say the confidence level is not the same as percentage of customers. Yu Jiang, you say 95% means confidence. Anyone else? Yes, so I agree. That is what the problem is here. It would be incorrect to advertise that 95% of customers expect to wait between these two time limits. The calculation indicated that you are 95% confident that all customers will wait between 1.99 and 2.33 hours. So be very careful when you're reading the question, when you're coming up with your analysis, because it would be unethical to state something like this. That's false information, and that's actually illegal to advertise false information. Okay, so I'm moving on to chapter 12, which is something different. It's about testing hypotheses. Before I get into chapter 12, a reminder for you to evaluate your courses. The place you would evaluate is qc.cuny.edu/evaluate. Now, this is not open as yet. It's opening next week. I believe on Tuesday next week, the evaluations will open. I know they did not have any course evaluations in the spring, but they are having it in the fall, and it's due December 14th. Why am I mentioning this? Well, for one thing, you're going to get one extra credit point if you complete this and submit it. So when you go onto this link, um, it's going to list all the courses you're registered for, and then you would select Econ 249. And once you complete the evaluation, there's a little box at the bottom or the next page that says, let my instructor know, or uh, inform or notify instructor, something like that. So as soon as you do that, I automatically get an email saying that student so and so submitted the course evaluation. So I know to give you that extra credit point. Now, I cannot read your evaluations. I cannot see what you have written. It's all anonymous, and I don't have access to it till the spring. So in the spring, I get to read all the comments, all the scores, again, without your name. So it's completely anonymous. And it's very useful information for me because I know what I should continue doing, what I should change. So it's useful, right? And for you, it's useful because if you are interested in registering for a course and you want to know about the course or the instructor, this is a great place to go for you because the courses are evaluated by students who registered for the course. So helpful information. Some questions in the chat box here. Priscilla, you say, can I do the same link for any course? I believe you can. You can evaluate any course because it gives you a list of all the courses you're registered for. But for me, I specifically want you to say notify instructor so that I know that you completed it. And it's not open till November 24th. They have not sent any email out yet about this. I'm just letting you know early so that you know that you're getting this extra credit point. And it opens on November 24th. So it opens next week on Tuesday. Okay. Any other questions for me before we start with chapter 12? So Alicia, to repeat it, the course evaluations are due December 14th. It's opening on November 24th, next week, Tuesday. If you complete it, you get an extra credit point from Econ 249. Okay? And make sure when you complete the evaluations, you check the box that says notify instructor. Okay, so I'm going to move on to the next slide. So starting with estimation, right? That was our last chapter. Hypothesis test is a procedure for making inferences about a population. So we have our population and we have a parameter of the population that is unknown. That unknown parameter could be the population mean or the population proportion. That's what we don't know. So we randomly select a few items from the population, that's our sample, and from the sample we come up with the result, which is called a statistic. And based on the sample statistic, we can make an inference or we can make a conclusion about the entire population. And then that's how we estimate our population parameter. So in the last chapter, we said we can use this method of estimation. And estimation was actually confidence interval estimation. In today's chapter, another way of making this inference, this conclusion about the population, is through hypothesis testing. So it's another phase of statistical inference, hypothesis testing. So reading the bottom, hypothesis testing allows us to determine whether enough statistical evidence exists to conclude that a belief, that is a hypothesis, about a parameter is supported by the data. So it's allowing us to find out whether we have enough evidence to conclude whether our initial assumption is actually supported by the data. So with confidence interval estimation, we used sample results to draw a conclusion about the characteristic of the population, to draw a conclusion about the population mean or the population proportion. Now, instead of an accepted interval, we can check our process. Does the interval contain the expected value? Does the process need to be changed if it does not contain that expected value? So this chapter, the first few slides today, it's going to be quite theoretical. It might be a little difficult to understand without me actually doing a problem and working out a calculation. But bear with me, we'll try to understand this idea of hypothesis. Um, I'll give you a quick example. Um, let's say there's a cereal company, and the cereal company states that they want all cereal boxes to have a certain average weight. They standardize it, right? And they say they put this stamp on the cereal boxes saying that the average weight has to be a certain amount. So for quality assurance purposes, they take a sample of cereal boxes and weigh them. And then they use some statistical method. Let's say they use hypothesis testing or confidence intervals. They do some statistical test or method to find out whether the true weight of all the boxes is what is expected, is what they expect it to be. If it's not, then they know the process needs to be changed. Something needs to be done. Okay, so let's first understand this idea of hypothesis. So hypothesis, that word itself, means it's a claim, it's an assumption, it's an educated guess about a population parameter. So you're making an educated guess about either the population mean or the population proportion. Those are the only two parameters. So for example, if I make this statement, the mean monthly cell phone bill of this city is mu equals $42. This is an assumption I am making about the population mean mu. So mu is that population mean. And I'm just making an educated guess about this particular parameter. I'm saying it's equal to $42. If I'm talking about proportion, remember proportion also means percent. So if I'm talking about proportion, maybe my assumption could be the proportion of adults in the city with cell phones is P equals 0.68. So I'm saying the percentage of adults in this city with cell phones is 68%. Again, it's just a hypothesis. It's a claim. So this is the formal definition for hypothesis testing. It's a step-by-step methodology where the differences between the results observed and the results expected are analyzed. So again, I'm going to underline this. A step-by-step methodology. So when I say step-by-step methodology, it's actually a 7-step methodology where the differences between results observed and results expected are analyzed. So we're trying to analyze to check whether what we expected is the same as what we observed or if it's different. Okay, whether what we expected is the same as what we observed or if it's different. If it's different, maybe it's greater, maybe it's lesser, but that's the idea with hypothesis testing. You're checking to see whether what you expected is the same as what you observed. So I'm going to switch now to a blank screen so I can write on it. And I'm going to first say that results expected, and we have results observed. So with results expected, we're going to call that H, capital H, subscript 0. So results expected is also called, well, I'll write that later. And results observed is denoted as capital H1, or it's also denoted as capital H subscript A. In your homework, you might see it as HA rather than H1, but I'm writing both for you. So results expected, HO, is denoted as, I'm sorry, it's called the null hypothesis. So HO is called the null hypothesis. It refers to the results expected. HA or H1 is called the alternative hypothesis, which refers to results observed. So make sure you understand the two types of hypotheses here. I'm going to spend the rest of the class time just defining and understanding what null hypothesis is and alternative hypothesis is. Okay, so any questions for me before we start? So we're going to begin with the null hypothesis. Okay, going back to the slides. So the null hypothesis, HO, states the claim to be tested. It states the claim to be tested. So hypothesis testing begins with an initial claim. Our initial claim is the null hypothesis, HO. So this statement here, the average number of TV sets in US homes is equal to 3. Now that's the initial claim. That's what we're stating initially. And the way you would write it is what's in the parentheses. So HO states that these two dots here is read as states that. So HO states that mu is equal to 3. Mu is your population mean. So mu, population mean, we're saying that the US homes has 3 TV sets. So mu is equal to 3. That's the first thing about the null hypothesis. You're stating the claim to be tested. So you're saying this is how it is right now, and this is what you're going to test. Maybe it's correct, maybe it's incorrect. The next point is that the null hypothesis is always about a population parameter. It's not about a sample statistic. So it's always about mu. We never write x bar because you're not making a claim about x bar. You already know what the sample mean is. That's easy to find. And you're 100% correct in your calculation about sample mean. It's not a guess. It's not an estimate. So your claim is always about the population parameter. Moving on to the next point about the null hypothesis. The null hypothesis begins with the assumption that the null hypothesis is true. So we're saying this is how it is right now, and this is true, and nothing needs to be changed. The initial hypothesis, HO, assumes that the process needs no corrective action. Okay, nothing needs to be done. This is very similar to the notion of innocent until proven guilty. So if I switch this to a court of law, it's the same idea. We're saying a person is innocent till proven guilty. We're saying the null hypothesis HO is correct, it's true, until you can prove that it's false, until you can prove that it is incorrect. So right now, we're assuming that the null hypothesis is true. Questions for me? Okay. Next point, the null hypothesis refers to the status quo. What's the meaning of status quo?
What's already been proven?
What's already been proven? Priscilla, you say something like a pattern, something common, not exactly. Oscar, I'll go with existing state. So the null hypothesis refers to the existing state, the existing condition, what's going on right now. So this is how it is right now. The null hypothesis is the existing condition. That's why we're saying that we're assuming it's true, it needs no corrective action, because this is how it is right now. This is what we expect it to be. The next point is that the null hypothesis always contains an equal sign. So first, let's fix this because this is not very accurate here. I don't know why it's not showing. This should say greater than or equal to. So you can see here that the null hypothesis always has an equality, an equal sign. And I'll show you what that means in a moment when I switch to the next slides. But remember that we always say that how it is right now. So that means it is always equal to something right now. So it always has the equal sign. And then finally, the null hypothesis may or may not be rejected. So if after your analysis, you find that the null hypothesis HO is in fact false, it's not accurate, it's false, now you may reject the null hypothesis. So if I go back to this court of law idea, you were able to prove that the defendant was guilty. Now it's the same thing as saying that you prove that the null hypothesis is false. Guilty, it's false. So therefore we reject the null hypothesis. But if you're unable to prove that the person is guilty, or you're unable to prove that this is false, then you do not reject the null hypothesis. Okay, so we have to bear that in mind. Your last two options with your decision is either you reject the null hypothesis or you do not reject the null hypothesis. Now let's switch to alternative hypothesis. The alternative hypothesis is denoted by H1 or HA. It's the opposite of the null hypothesis. That's what you have to remember. It's always the opposite. So this alternative hypothesis is the opposite of HO. So for example, the new statement would be the average number of TV sets in US homes is not equal to 3. So that's the opposite of equal to. So we say it the same way. H1 states that mu, the population mean, mu, remember you're still talking about the TV sets, is not equal to 3, the exact opposite. So if it's the opposite, that means the alternative hypothesis is challenging the status quo. It's challenging this existing condition. It's saying this is not how it is right now. It's different. It's not equal to 3. Next point, H1, the alternative hypothesis, never contains the equal sign. So again, let's fix this. This should be greater than or equal to. It never contains the equal sign. So it cannot be equal to that. It has to be the opposite of whatever your null hypothesis was stating. So again, I'm going to write this out in a blank screen on the next slide to show you the difference between the null and alternative hypotheses. And then finally, with the alternative hypothesis, this is the hypothesis that the null hypothesis may be false. So H1 is anticipating the possibility that HO may be false. That's the whole idea, right? You're testing to see that it could be false. That's the idea of your hypothesis test. Questions for me? Okay, so I'm going to a blank screen so that I can show you some of the differences here between null hypothesis and alternative hypothesis. So with the null hypothesis, you have HO, and with the alternative hypothesis, you have H1 or HA. So I'm going to write both again because your homework has both, or it might have HA in it. So I said that the null hypothesis always contains an equality. So let's start with the first example that was given. So if my example says that the average number of TV sets in all US homes, so population mean, is equal to 3, and I'm doing this exercise or this experiment and I want to find out if this is true or incorrect, then my next step would be to state my alternative hypothesis, and my alternative hypothesis has to be the exact opposite of the null hypothesis. So the alternative hypothesis states that mu is not equal to 3. And then I continue my hypothesis test, which is a series of 7 steps, and I will try to prove whether HO should be rejected or not rejected. I will try to prove whether this claim, this initial claim about the number of TV sets is accurate or inaccurate. Okay. If I was doing something about proportion, so this is a different example, right? Let's say I have an initial claim, so HO states that the proportion of adults in US homes in this city, the proportion of adults in this city with cell phones is greater than or equal to 68%. I could leave it as 68% or say 0.68. So I'm saying this is how it is right now. This is the existing condition. The initial hypothesis states that population proportion is greater than or equal to 68%. Well, if I want the exact opposite of this, how would I write it? H1 states that, what should I say? What's the opposite of greater than or equal to? So, Xiaoting and Abraham, you're right. Remember, Jason, you can say equal to. So that's the only thing that I would disagree with. Oscar, you're right. So it should be less than. I cannot put the equal to sign because the alternative hypothesis never has an equality. It never has an equal sign. So it's just less than. Let's do one more. The initial null hypothesis states that, let's go back to mean, the mean monthly cell phone bill of this city is less than or equal to $42, right? That's what that example said. So again, that's an initial claim. You're going to try to prove whether this is right or wrong. So the exact opposite would be the alternative hypothesis states that the mean monthly cell phone bill is, Diana, you said Jeffrey greater than, right? Yep, you got that. So greater than $42. So that's the exact opposite. Now, you have to remember that with the alternative hypothesis, when you're doing the alternative hypothesis, you have to state whether you're dealing with, now I'm going to type it because it's neater, a two-tail test. Whenever your sign is not equal to in the alternative hypothesis, you should note that you're always dealing with a two-tail test. Otherwise, you're dealing with a one-tail test. Okay, so typing this here. So make a note that if alternative hypothesis is less than or if alternative hypothesis is greater than, you have a one-tail test. Otherwise, you have a two-tail test. And what does that mean? I will explain in a moment, but put this note somewhere. Questions for me? Okay, so moving on to the next slide. So now that I've explained sort of the differences theoretically between null hypothesis and alternative hypothesis, the next step is to discuss the 7 steps in your actual hypothesis test. So step 1, you know, is to state the null hypothesis. So this you already know. The null hypothesis states that mu is equal to mu 0. So now what's mu 0? Mu 0 is your, I'm going to type it in here, make it a little neater. Expected population mean. So mu 0 is your initial expected population mean. So it's saying that HO states that mu is equal to that value, that expected population mean. Now that example is just about mean, but you could have also had a statement about the null hypothesis when you're dealing with proportion, right? And I gave you that example before. Your null hypothesis could state that the population proportion P is equal to P0, and P0 would be your, I'll type it in here, expected population proportion. So if you're dealing with P, that's proportion. So P is equal to that initial expected population proportion. So that's your step 1. State the null hypothesis. It depends on the question. It depends on the experiment that you're doing. Step 2, choose an appropriate alternative hypothesis. So now state your H1 or your HA. So now if H1 states that mu is not equal to that initial expected population mean, then you're dealing with a two-tail test. If H1, and I'll write a different one here, if H1 states that your population proportion is less than the initial expected population proportion, then you have a one-tail test. So remember, H1 is the exact opposite of HO, and it never contains an equal sign. Okay, and same thing here, if you're dealing with greater than, this becomes a one-tail test. Step 3, choose a significance level. So your significance level is alpha. And you've seen alpha before. It's basically your risk level that can be tolerated. And as we saw, this is usually given to you in your problem, right? You're told how much error is allotted. What's the amount of risk level that can be tolerated? But now I'm going to say that with hypothesis testing, error also has a different name. It's called type 1 error. So type 1 error refers to alpha, type 1 error. Questions? Okay, moving on to step 4. So when you do a hypothesis test, we're actually going to do it in these 7 steps. And I'm not going to do an actual calculation today, but you need to understand what these 7 steps are. So step 4 is to select the appropriate test statistic. Okay, so this is going to be a new calculation, test statistic. And the test statistic could be Z observed. This is your observed value. So the subscript is OBS. Z OBS means Z observed. So if you're doing a hypothesis test for population mean and sigma is known, your population standard deviation is known, then you would do a z-test with z observed. If you're doing population mean and sigma is unknown, now we know that we are going to use the t-table. So that means your test statistic value is going to be t observed. So t subscript OBS. And we use the t-table to get this. So this is t observed. And then finally, when you're doing a hypothesis test using proportion, just like confidence intervals, proportion always uses the z-table, which is z observed. Okay, so those are the two test statistics, either z observed or t observed, just like your confidence intervals. Step 5 is to establish the critical region. So this means you're drawing the graph. You're drawing the graph, you're shading the area that is critical. So check your standardized normal table and the alternative hypothesis, and you will also check something called the p-value to know the degree to which it supports or rejects HO. So when you draw the critical region, the hypothesis test has really two methods. Either you use the rejection method or you use the p-value method. And my charge is really to teach you both because you need to know the difference between the rejection method and the p-value method. Some instructors, some textbooks prefer one over the other. And in the real world, I would say the p-value is used more frequently than the rejection method. But again, I have to teach you both. And in your homework, you're asked to answer the question in both ways. So you're asked the rejection method and the p-value method. And if you take Economics 382, I don't know who your instructor is, they might focus on one over the other. So again, you need to know both. So that after you draw your graph in step 5, that brings you to step 6 to make your decision. So again, your decision is based on one of two methods, right? Method 1 and method 2. So your first method is your rejection method. So the condition is this: you reject the null hypothesis if Z observed falls in the rejection region. Now, what's the rejection region? Once you draw your graph, and I will explain how to draw your graph when we actually do a word problem. But understand that when you draw your graph, you're trying to see where this calculated t statistic value that you got from step 4, where it falls on the horizontal axis. And if it falls in the center that is not shaded, then your decision is do not reject the null hypothesis. If this z observed value that you calculated from step 4 falls in one of the shaded regions, then your decision is to reject the null hypothesis. The p-value is similar, but it has a different condition. It doesn't follow this condition, and I will mention that in the next slide. And then finally, step 7 is to explain your result, your conclusion. You don't give your answer in terms of reject and do not reject. If you're talking about number of TVs in US homes, then you have to explicitly state, well, they don't have 3 TVs in US home, the average is not, or it is. So that's your conclusion. So now going back to this idea of p-value, where are we getting p-value from? What is that about? So the decision is based on evidence using p-value calculation. The p-value is the probability of seeing data like these, given the null hypothesis is true. So this is the condition. You reject the null hypothesis if your p-value is less than your alpha. So by looking at the graph, you can figure out what your p-value is. And if your p-value is less than your level of significance or your type 1 error or the risk level that can be tolerated, if it's less than, then we reject the null hypothesis. We say that the null hypothesis is not true, that initial claim is false. If the p-value is greater than alpha, then we do not reject the null hypothesis. Questions for me? Okay, so moving on to the next slide. Let's go back to that idea of court of law. So the initial hypothesis states that the defendant is innocent. I'm saying that it's true. The process is true. It's correct. The defendant is innocent. Now, the opposite is what I want to anticipate that it's not true, right? So the opposite would be my alternative hypothesis states that the defendant is guilty. Is guilty. Okay. So now let's say I do my 7-step methodology and I find out that the p-value is less than alpha. So my condition is this, right? I would reject the null hypothesis if my p-value is less than alpha. Okay, so we found that p-value is less than alpha. Now I go back to this and I say I reject it. This is not correct. I reject it. So now I can say that I have enough evidence to prove that the defendant is guilty. So just like that, I'm able to say that the defendant is guilty. If I do my hypothesis test and I find out that p-value is greater than alpha, okay, it's greater than alpha. So let's erase this. Now I'm saying that I do not reject HO. I do not reject it. So this is fine. But if I do not reject it, that doesn't necessarily mean that the defendant is innocent. What that means is I didn't have enough evidence to prove that the defendant is guilty. Now there's a difference with that. I'm not saying that the defendant is innocent. I'm saying I didn't have enough evidence to prove that the defendant is guilty. So that's why we never say accept the null hypothesis. We always say we do not reject the null hypothesis. So those are your only two options. Either you reject the null hypothesis or you do not reject the null hypothesis. We don't accept the null hypothesis. It's the same way as saying the defendant is guilty and the defendant is not guilty. Just because the defendant is not guilty doesn't necessarily mean that the defendant is innocent. You just couldn't prove innocence. Any questions for me? So again, a little theoretical here, a little hard to comprehend unless we actually do a problem together. But this is how the chapter is going to be divided up. First, we're going to perform a z-test for the mean when sigma is known, and we'll do both one-tail and two-tail tests. Then next, we'll do a t-test when sigma is unknown, and then a z-test for proportion. And so these are how the next 3 classes will be separated. We'll be doing these 3 sets. And while you do the hypothesis test, you're going to discuss the p-value approach to hypothesis testing, as well as discuss ethical issues. Any questions for me? Okay, so I'm going to pause here and switch now to something a little different. So I'm going to share with you a 5-minute video, and I would like to discuss it. So again, if you're not comfortable with your microphone on, you can type it into the chat box, but remember all this is included in participation, right? Okay, so sharing the video. And as soon as the video ends, I would like you to tell me what your first thoughts are about the video, and then we'll get into the discussion questions. Okay, so sharing my screen.
I'm Ryan.
My name is Mai.
My name is George.
I'm Hector Sanchez,
And
and
I
I
believe
believe
in
in
racial
racial equity.
Because of our history as a country. If we look back at America from its inception, we know that racism plays a big role. We know that racism is embedded in every aspect and facet of our nation, especially education. So in order for us to dismantle a culture that disenfranchises specific groups like Black and brown people and indigenous people, we need to bring racial equity to our school and actively be anti-racist in our school.
We need racial equity in our schools because our society needs beautiful thinkers and readers and creators of all stripes, and we're still crawling out of a 400-year hole of unequal access to opportunities with a child's right to high quality education.
I think it starts at large with our teachers. And we need our teachers to be able to understand and believe in all children, in particular our students that have been deemed by media, politicians as incapable of learning. I think efficacy is a real piece. If our teachers really believed in that our students could learn, if our teachers were even able to engage them in particular curriculum.
The educators. Personally, I don't believe that there are enough male educators in education. There are definitely not enough minority educators in education, in the public education system, and our students need that. They need that representation. They need someone to be able to relate to and to look up to. Another one is educators not really knowing, or they're not willing to know, or they're not willing to learn about the life of a minority, to take a walk in our shoes, learn what we're facing, learn our struggles.
Another barrier is disengagement because of the curriculum, not having enough diverse curriculum for students of color to feel empowered, to feel like they belong to a community. So I think that a lot of the work has to do around diversifying the curriculum and introducing different perspectives on things so that students feel a sense of ownership over what they're learning.
Those of us with supportive administrations might have the chance to start conversations and programs that bring students and staff together in brave, tough conversations about racism in our schools. For everyone else, sharing our own stories, showing that racism doesn't have to be and usually isn't capital R viral video situation. We as teachers and as Americans are racist because we work in a racist system. And the sooner we admit that, the sooner we can keep doing the work.
If you are not going to believe in children, love children the way you need to as an educator, and moreover hold on to these biases and be racist and in practice and in theory and sometimes in just in your belief, then we're really struggling. If there isn't a mandatory implicit bias training for teachers to go through, that you as a teacher should demand it.
We need them to see educated minority males, educated Black males, educated Latino males, to let them know that that's a reasonable goal. You can grow up to be whatever you want to be, but they need to see that success, and they need to see that Black men do care about education.
Okay, your thoughts?
I do agree, but I didn't see any amount of proof to this. I do agree with what they're saying. I just didn't see
Mm-hmm.
any evidence.
Okay. Eli, you say very moving. I think what he's trying to say is actions speak louder than words. Alicia, what do you agree with? Marco, go ahead.
I was just going to say that the message of diversification in the video is very important. I feel like it reflects to like this era of globalism that we live in. Because of globalism, people have been able to learn about other cultures and other traditions, and that has broken down stereotypes that people have built over the years simply because they haven't interacted with others, and these stereotypes have flourished because they weren't willing to or able to interact with others, and by diversifying, the classroom or the curriculum, students and teachers are able to receive a different perspective and point of view and learn and build upon that, and change their own beliefs. It's like when it's like college and higher education. Um, people tend to say that when people graduate, they graduate with a more left-leaning perspective, but I
Mm-hmm.
feel like that's only because you know, at a higher education institution, you're able to, meet, interact with others, and read literature that you might not have chosen to read on your own. And because of that, you have a more global perspective on things, and that just helps interact with others.
That's an interesting point. That's excellent. I'm going to go back to what Alicia has stated here. Alicia, go ahead.
So, in the video, it was like mostly minorities talking, and I feel like that's kind of like evidence, because like they wouldn't say what they've said if they didn't feel like if they had that representation to look up to, they would have felt like they could strive to do better, and like that's their experience, and like evidence is collected through surveys, right? So this is kind of like their way of like saying, if you do take a survey, this is the results you would get. Seeing representation of their own kind would like make them strive to do better, because it like gives them some type of belief.
Yes, so I agree. And I'm going to go back to what Priscilla mentioned, and I think there was someone else who said that you see that they're saying that racial inequity is important to discuss and confront in discussions and in schools and in curriculums, but you're saying that you don't see any evidence. So that's what's bringing us back now to statistics. So I'm going to quickly read what Urmila says here. The video does make a point, but some things, especially when he said there aren't enough male teachers, I guess that need support because they may depend on education level. Okay, so if we talk about evidence and we look around in society, my first question to you is, what is the data telling you? Okay, if we say that there's no evidence, let's look at the US Census that was sent out, and
Uh,
let's say they collected all this data.
I'm sorry, can I add something else? Because I
Sure.
feel I feel like the evidence is out there. I think I saw maybe a couple years ago there were in the subway some ads about, being a male teacher. It's just that in the video they never show it. So I feel like the evidence it is out there about this video. It's just that
So
they
just to give you some background, the video was put together by teachers, and they are teachers from high school through middle school. And they are part of CUNY's Black Male Initiative that's promoting teachers and specifically male minority teachers to go back into the education system. So that's their project that they're particularly doing. But my focus is, okay, we hear about this racial inequality in society, social injustice. So let's go back to the numbers. Let's actually look at the evidence first. If we look at the US Census questionnaire that was sent out, and let's say they collect all the data, and we find that there are certain ethnic groups that have a higher percentage in certain communities, in Queens, let's say. So now what? So what can we do about that? What has that got to do with fixing racial inequity in society? So you find out from the census that there's a higher percentage of certain ethnic groups in certain communities, counties. Priscilla, you say start with ourselves. What do you mean?
Well, I mean, what you were saying about the problems that there may be in the society when we have like racial situation in education. So I believe that if you start with yourself, like recognizing that that does exist, if you like spread the awareness to respect others and respect like different kind of racial problems and just like respect inclusion, then I believe you will kind of like start solving the problem.
Okay, so if we know that there's higher percentages of certain ethnic groups in certain areas in Queens, now programs can be implemented. So now we can start to see that there's a pattern. Maybe certain ethnic groups need more resources. So we could uh, send different resources for certain ethnic groups and initiate programs to help raise the standard of living in society. So that's one thing. My second question is, now you've collected data and you've learned about regressions, you've learned about correlations. So now you're ready to make predictions. So let's talk about hiring practices. Once you graduate and you see that there is some correlation with hiring practices. Maybe it has to do with gender. Maybe it has to do with something else. Tusha, you say, is it like taking a survey for these ethnic groups, asking them what would help them? That's one way of seeing how you could help them. So that's relating to the first question. Now focusing on the second question, I'm saying that if you can understand what the data is telling you with correlations, and let's just focus on hiring practices, what can be done about that? So again, the data is telling you something about hiring practices, correlations between something, either with employment. So how can you fix this systematic racism that we seem to have in society? Marco, go ahead.
Can you hear me now?
Yep.
I would say is that if we discover that there's like, let's say this disparity against women in hiring practices where, they're unable to achieve certain positions in management, I think one of the ways that we could break that barrier is that instead of them, once graduating, working for someone else, letting them start their own business and providing, loans so that they can do that. I feel like that's one way that could fix the issue.
That's a great idea. So maybe there's past historical data that shows there's a correlation between women-owned businesses and success rates. That maybe that's what the data is telling us. I agree. So, Oscar, you say that employing affirmative action is one, affirmative programs. Um, Eli, you say it can be detrimental to some people, giving loans, and can put some people in the hole. True. So we have to listen to the data. The data helps us make these correlations, helps us make these predictions. So it's not enough just to go with our belief or what we think should be done. We have to listen to what the numbers are telling us. So maybe you see a video like this and you don't think there's evidence, but if we collect the evidence, maybe what they're saying is true. So, is the data showing you that there's an even number of male and female in hiring practices? Is the data telling you that there's enough black males who are teachers? Um, like you mentioned earlier, I think it was Alicia, children need to see someone who looks like them so that they can relate and believe, and they can also achieve higher. That brings us back to higher education. So with higher education, it doesn't just start in kindergarten, right? In our courses, do we have diversified curriculums? Are you learning about data that applies to all kinds of ethnic groups? For this course, for example, is your textbook, are the examples that we discuss, are they covering every socioeconomic level? Does it make sense to you? Are you exposed to data from Thailand and comparing it to South Africa? These are things that once, like you mentioned, Marco, once our mind is open, it doesn't mean that you should turn left or right or lean left or right. It just means that we're at least discussing that there's racial inequity and we're listening to the numbers. We don't have to make decisions without using systematic methods, right? These are analytical methods that work. So my last question to you is, once you analyze the surveys and once you do your studies, and if you read articles and watch TV and watch social media, how do you know, what are the questions you're asking? How do you know that is a valid conclusion, the validity of their conclusions? What's going through your mind? What do you ask? So you have to remember about this idea with bias. Um, what's the source? Where did it come from? Who is writing the article? Is there any bias involved? Is there a reason why they are making you lean towards a certain conclusion without writing objectively? When you see something, you should always be presented with both sides for you to make the decision. These are what the numbers say, this is what the analysis is, this is the conclusion. You make the decision. Okay, that's all for today. So I'm going to stop here. If there aren't any more questions, I'm going to stop recording.